So what you can see on screen at the moment is a summary really of what we've got so far. That b to the power of t can be written down as e to the power of ct, where c is equal to log of b and b is equal to e to the power of c. That's the key thing here. So what we're going to do now is have a look at some of the questions from C3, exercise 5b. And in question 1, they want us to write down, in part A anyway, 10 to the power of x in the form of e to the cx. Okay, so from doing what we've done so far, we've got this rule up here, and this is effectively what we're doing. So we know that the c here is log of b, and b here is 10. So what we've got here is this is the same as e equals c, and c is the same as log of b, and the x is still there. So I've got e to the log of 10 times x. That's just from using the rule. Now if you go to a calculator and work out what log of 10 is, ln of 10, log of 10 is 2.30. So I can replace the log of 10 with 2.3, so I get 10 to the power of x is exactly the same as e to the 2.3x. So I've rewritten this one with no e's, this one with an e. And if you want to check, that should, well, if we say that x is 5, just make up any number you like, 10 to the power of 5, what's that? That is 100,000, 10 to the power of 5. Now check this one, e to the 2.3 times by 5, just replacing the x with the 5. 2.3 times by 5, 11.5, and e to the 11.5, 98,715. Now hang on, that's not quite the same. The only reason it's not the same is because of the rounding errors, because that wasn't actually 2.3. That was log of 10. So if I do that again, if I did log of 10, is that value there, slide the calculator over here, I'm timesing that by 5, and now I'm doing e to the that, I do get the exact 100,000. But because I rounded here, I've got an approximate answer here, but it is just to show you that that does work. So let's have a go at doing part B. In part B, they want us to rewrite 0.1 to the x in the form of e to the cx. So the key thing is this will be e to the log of 0.1, log of that thing there, times by x. And if we do on a calculator log of 0.1, log of 0.1, that comes out to be minus 2.3. So this is the same as e to the negative 2.3x. Those two things are equal to each other, they're equivalent in every way. If we move on now to question 2, in question 2 they've got in part A 3.6 times 1.1 to the t, they want to be rewritten as a e to the ct. Well, the 3.6 and the a, they match up. So what we've got to worry about here really is this changing 1.1 to the t into e to the ct. From what we did last time, we just do e, the c is log of that number, so log of 1.1 times by t. Log of 1.1 we can work out on a calculator, and if we do that on a calculator, log of 1.1, we get 0.095. I'll just write that down over here. Is 0.095. So the answer we need for this question will be 3.6 e to the 0.095 t. And that, and what we had to start with, are equivalent expressions. Whatever value of t you put into here, you'll get the same value out as if you put it into here. So if I go at part B, when they're asking us to rewrite 0.342 times by 5.71 to the t in the form a e to the ct, we can do this fairly quickly. The a will be 0.342, and here I have e to the 5.71, log of 5.71 times by t. If I log 5.71 on the calculator, that's giving me 1.74, so I get 0.342 e to the 1.74 t, and that's how I do part B of question 2. Moving on to question 3, part A, they're giving us 100 e to the minus 3t, and they want us to write that as a to the bt. Okay, well the a will be the 100. Let's just think how we can rewrite this. I can rewrite this e to the minus 3t as e to the minus 3 to the power of t, using the law of indices before, that if a power to a power, you times the two together. E to the minus 3, remember, that's just a number. If you get your calculator and do e to the negative 3, that is 0.05. So that's the same as 100, 0.05 to the power of t. There we go. That's the answer. It's all we had to do in that question. So if you just break it up like this and then change that into a number, where there used to be an e in the expression, that was our starting expression. In this one here, we got rid of the e. We have an equivalent expression without the e in there. And if we look at part B, where they're starting with 2.83 e to the 1.46t, you can think of that as 2.83 e to the 1.46 to the power of t. And if you do on the calculator e to the 1.46, you get 4.306. And that is to the power of t, and at the beginning is being times by 2.83. So our starting expression changes into the expression down here. That's how you do question 3. In question 4, they give you an expression for log of y, and they want you to get that in an expression of y in terms of x. So, okay, I think that's fairly easy. Let's get rid of the logs. How do I get rid of a log? I do e. So I can get rid of the log here if I do all of this side as e to the power of. Okay. Now you've got to do a bit more work than that. They want you to manipulate some of these things. Using the laws of indices, if you're adding inside the power, that was the same as when you were multiplying things together. So that should be an e there and then 0.6x. So e to the something plus something is the same as e to the first thing multiplied by e to the second thing. So I've got here e to the 0.4 times by e to the 0.6x. E to the 0.4, that's just a number. We can do it on a calculator. E to the 0.4 is 1.49. So this is now y equals 1.49 e to the 0.6x. And that is quite acceptable as your answer. You've done the simplifying. You've got it here as y equals some function of x. You can actually go one stage further. You can get rid of the e altogether from what we did earlier. From what we did earlier, we know that that could be written down as, well, this bit here, e to the 0.6x is the same as e to the 0.6 to the power of x. E to the 0.6, that's just a number. Reach for your calculator. E to 0.6, that's the same as 1.82. So this becomes, instead of e to the 0.6, 1.82. So I can rewrite my answer if I want as 1.49 times 1.82 to the power of x. Both of those arrowed lines there are fine as answers. But we've got rid of the log y. We've now got an expression for y instead of log y. Finally, what I'm going to do now is work through question 4, part C. To do the same thing, we've got log y, it's supposed to be an ln there, is 0.7 plus 1.7x. We want to rewrite it as y equals. So if I get rid of the logs here, I've got to do the e to the power of over here. Where I'm adding, that's the same as e to the first thing times by e to the second thing. e to the 0.7 is just a number. You can work that out on the calculator. That's 2.01. So I could, if I wanted to, leave my answer like that. If I want to remove the e as well, remember that e to the 1.7x is really e to the 1.7, or not really, could be written as e to the 1.7 to the power of x. And e to the 1.7, again, it's just a number on your you can work out on your calculator. E to the 1.7 is 5.47. So you could write your answer down with no logs and no e's as that bit down there.